And now with respect to output gate also we need to find, and here we get dot, this is ot, and these are the equations which are required, and yt by ht, yt by ht by ct we will not do, we will do ot because we need to find till ot only. So dht by dot we can do, yeah, that's if you substitute you will get these things. And pretty much I think dh tan h, this thing is like a constant, we are with respect to this we are doing, so we can just substitute like something like this, so this comes like this. So basically you can just derive those differentiation, and that's basic only. And then dl by dit which we are doing, that is nothing but we can again start from yt, then yt by ht, dl by dy by dht, right? Then dht by dct, ht by dct, then dct by dit, because till here earlier we used dct by dgt because we are stopping at gt, now we are stopping at it. So with respect to it, wherever we are stopping or with respect to what we are doing till there, so this is a basic intuition. We should follow dependent independent variables game and back propagation, like this. By changing this thing is changing, so we whatever the derivative with loss with respect to this what we are getting it, we need to back propagate to it's on the variable it is dependent on. There's a basic intuition also you can say, or dependent independent game and chain rule also. So these are the intuition how backpropagation mainly works. So, and again derivative game, whatever the nudging you are doing to the loss, and with respect to this how what we change, how this is changing the slope thing which I have shown. So that is also an intuition. Now so these are the equations which are used here to solve this. And now lastly forward gate, again we can start by dl by dyt, and then dyt by dht, dy by dht, and then dht by dct, dht by dct, till here we get, because forward gate is over here, so dct by dft. So right, we will just substitute and we will get the answer. I think you got this, how we are solving gradients for candidates till now, everything. Now we have solved gradients for states, like now we have solved derivatives for states. So state gradient has been solved like ht, ct, dht, dct, short forms which I am using, and then dgt, this is nothing but dgt. Then gradient with respect to gates also, dot, dit, dft. So we have solved this. Now we are ready to solve the gradients with respect to weights. So dl by dw, so for that we need to get states and gates are required in the like pre-processing. Now this information is required to calculate this, you can think something like this. So first we will start by dl by dv. V is nothing but whatever the weights we are assigning to output, as we have seen in the RNN. So here we have v for suppose, and weights, whatever we are passing this here weights, and his input inside one cell itself I'm talking about, not like each cell. This is completely one cell. So you know the LSTM structure, right? Inside there will be different paths, different activation functions which we use, and as I have shown, different states are there, different gates are there, and again like this other cells will be there. So first we will talk about dl by dv, sorry. So talking about dl by dv firstly, so how we can calculate is like dl by dy hat by dzt, because as you can see we are here, this is nothing but vht, then dzt by dv, because still we are with respect to v we want to differentiate, we will get something like this. So, and now we need to calculate these things as we have previously, like at first we have seen, right? We need to we set a goal, we need to calculate these things. So first we are focusing on this now. First with respect to input weight, how we can do is, again we can start from dl by dit. We can just directly start from dit because we have calculated till dl by dit. So input gate, because input weight is over here only, so with respect to we can start by with respect to this we can start, and then di by dwi, because with respect to wi we need to go. So what I'm saying is, this is independent, this is dependent, so this is dependent on this wi. So we need to find the derivative of this with respect to this as a chain rule here. And at first we need to find the loss with respect to WT, the IT, which we are doing over here. Then as a chain rule we need to find the differentiation of this with respect to this, because this is dependent on this is independent. So, and again simple chain rule you can apply, and again independent dependent game you can play, or back propagation, it goes something like this. Whatever changes we are doing here, this changes need to be passed to here. So whatever changes we are doing here, DL by DIT, those changes need to be passed over here, because this is dependent on this. And those intuition, independent dependent intuition, derivative intuition, how derivative nudging the value of bottom one changes the impact of the top one, like gradient descent what I have shown. And again chain rules, all those intuition you can apply. So if we will solve and calculate this, we'll get result something like this.